All right, let's look at our next example. Different forces are applied to a rod which can rotate about an axis at its end. How large would the force F have to be in order for the rod to be in rotational equilibrium? All right, so a new definition here, rotational equilibrium, just means that the bar is not rotating when we add up all of these torques. And so that means the net torque has to be equal to 0. And so we're going to approach this much like we did the seesaw. We want to calculate the torque from each individual force, and then we can consider what the net torque is in order to find our unknown. So I'm going to label these. It has the axis of rotation labeled down here. Let's go ahead and label each of our known forces. I'm going to say the 3 Newton force is force 1. The 1 Newton force down here is force 2. And the 1 Newton force at the very end, pointing down and left, will be force 3. So again, we want to start with calculating what is the torque from each of these forces individually. And so for force 1, the torque from that force, I'm going to use subscripts just to keep it very clear. This will be torque 1, R1, F1, sine theta 1. Again, just because we want specifics, we need the distance from the axis of rotation to force 1. We need force 1 itself, and we need the angle between R and F1. And so looking at this, that distance is 1 meter. The force itself is labeled as 3 newtons, and the angle between them, it's not explicit, but this is supposed to be a 90-degree angle. This is a perpendicular situation. So we have 1 times 3 times sine 90. So 1 times 3 times 1 is 3 Newton meters. And then just taking into account the direction that this torque would cause our rod to rotate, looks like clockwise. All right, so that is for the first force, and we're going to repeat this process for the second force now. So for the second force, we're finding the torque due to the second force. So R2 F2 sine theta 2. And so again, make sure you're using the distance all the way back to the axis of rotation. And so that's going to be adding those two distances together. So 1 plus 2, that gives us that full length of the lever arm, so 3 meters. The force 2 is 1 Newton. And again, this is another perpendicular case. So we have 3 times 1 times sine 90, which will also be 3 Newton meters. And then looking at the direction, this also would cause our rod to rotate clockwise. All right, there's our first two. Repeating the process for our third known force here. So tau 3 is R3, F3 sine theta 3. All right, the distance, well, it's also all the way at the end of the rod, so 3 meters away. The force here is also 1, but we want to be careful of the angle. So 3 times 1 times sine. This one is not perpendicular to the lever arm. The lever arm is, of course, pointing up and to the right, and then this force itself is pointing down and to the left, parallel to that direction, but in the opposite direction, right? So it's a 180-degree angle. But sine 180 has kind of a special value worth remembering. It's 0. So it doesn't even matter how much that force is. There is no torque caused by that force. All right, so that's our first step. We need to calculate what is the torque from each of these forces individually?